In this lab video, I'm going to go over a brief introduction to experiment 4 and go over the calculations for the post-lab. In this experiment, we're working with a mixture, so it's a heterogeneous mixture of copper 2-sulfate pentahydrate and sand. We're going to separate the copper 2-sulfate pentahydrate with extraction and filtration, and we will then recover the copper 2-sulfate with crystallization. Just to go over their quick roadmap briefly, so we have a mixture of the copper 2-sulfate pentahydrate and sand. You'll see a photo or a video of that in our video. We're going to add water, and the only thing that is going to dissolve in the water is the copper 2-sulfate pentahydrate. This is an ionic compound, and we saw that in your previous experiment. If you look at the solubility chart, you see copper 2-sulfate is water soluble. Sand, from your experience of going to the ocean or seeing pictures of the ocean or the beach, you know that sand does not dissolve in water. So we're going to add water. The copper 2-sulfate will become aqueous. The sand will stay solid. And then with filtration, so pouring it through a filter paper, just like if you've ever made coffee, everything that is water soluble dissolves in the water and goes through the filter paper, and all of the coffee grounds stay in the solid form. And then we're going to have our aqueous copper 2-sulfate, and if we heat it, the water will evaporate off, and the salt, the copper 2-sulfate, will remain a solid. And this is called a hydrate. So for every one copper 2-sulfate ionic compound, we have 5 water molecules bound together. And this is just the most stable form of this compound. We call this a hydrate. Copper 2-sulfate penta, because there's 5, hydrate. And we're going to be able to obtain or recover the copper 2-sulfate pentahydrate and to determine the mass of this. The other side of this solution map, we have our sand that is wet in the filter paper. We're going to dry it. In the video, we actually use an oven, and we end up with the dry sand in the filter paper. So looking at some definitions, here we need to update this for the current lab manual. This should actually be the mass of the mixture started with. So our definition of percent composition A or B, so this would be, in this case, percent composition copper 2-sulfate or pentahydrate, or percent composition sand. So mass of the pure component divided by the mass of the mixture that you started with times 100 to make it a percent. The next definition, percent recovery. We're looking here at the sum of the mass of both components recovered. So you get the mass of the copper 2-sulfate that you recover, the mass of the sand that you recover, add them together, divided by the mass of the mixture that you started with, times 100 to make it a percent.